doing this right now. This is probably one of the harder ones. We're optimizing areas, just length times width, given a amount of feet of something. So we need to draw a picture. Sometimes it'll be like a normal rectangle, x times y. Sometimes you'll only need one y instead of two y's. Sometimes you'll need three x's instead of two y's. So this is how we're going to find our perimeter equation. These are the only three I'm really going to focus on, just so you know. So we're just going to follow these steps. So let's just jump in it and follow these steps. So first, let's draw a picture. You have 500 feet of fence in a large field. You want to construct the rectangle for a playground. What is the largest dimensions? So why we have to use quadratics is because that's how we find our maximum. Maximum is your vertex. So we need an equation to give us a vertex. So the first equation we're going to come up with is the perimeter after we draw a picture. So just a rectangle, nothing special to it. Rectangle, x by y. Perimeter of this would be 2 x's and 2 y's. So 2x plus 2y equals 500. For some reason, this is what people find the hardest in this unit, so I'm just recording this whole class today. And we can, if you need to go back and look at one example, you can, or two examples, you can. If you want to, I'll just post it. Okay, so this is my perimeter equation. It equals 500 because fencing is perimeter. 2x plus 2y equals your perimeter. Solve the perimeter equation for y. Solve our perimeter equation for y. So I'm going to subtract over my 2x, then I'm going to divide everything by 2. No. So I'm going to subtract over 2x, so 2y equals...
Oh, that's what you meant.
And then divide everything by 2. So that'd be 250 minus 2x. Minus just x. Let's try that.
What if I subtract 2y? Does that matter?
Then you'd be solving for x and not y.
Yeah.
Well, I thought S goes first.
If you want to, but it'd be negative x plus 250. You like that better? All right, what we're trying to do is maximize our area. So we need to have a quadratic equation for area. Well, area is length times width, or in this case, x times y. To graph it, we can only have 2 variables, one x, one y. Right now we have 3 variables, a, x, and y. So we need to change this y in forms of x. So my area equals x times 250 minus x. Replace your equation of y in here. In here. Here. And now we have a quadratic equation in terms of x that we can find the maximum or the vertex of. So my area equation that we're going to find the maximum for is 250x minus x squared. You're going to have Desmos for this whole test. So if you want to graph it in Desmos and find the maximum, that's fine.
Does it matter which way you put it?
You can rewrite it.
How do you know not? Why did you look for the y first? Did you look for the x first?
You could. It's really confusing. I'll show you that in a second. Find the vertex, however you want to. It's standard form. X equals negative b over 2a. You can find the vertex that way. You can find it through Desmos by graphing it and just clicking the very top button. There's different ways you can find your maximum. If you're doing it by hand, remember x equals negative b over 2a. This is to find the vertex, the maximum, because we're trying to maximize the area. We'll do it by hand, and then we'll look at the graph as well, just to show. Have I lost anybody yet?
Yeah.
What?
Yeah. I
I
got
was
to go.
saying that as a joke. Really? I lost somebody?
I got up.
Is the A area?
A is area.
Wait, where did B come from?
No, A is apple.
Ooh.
AX squared plus BX plus C.
I know you wait for me to sign. What he said.
I think it's like an apple color.
What?
That's totally what it is.
It was like one of those like.
It looks like an orange circle. I don't
What
think.
does?
What's that? 125?
That does.
He's looking on my board.
Which one?
125.
How did you find that out?
Are you?
Isn't it A?
Oh,
no, that's the vertex, right?
Vertex. We're looking for the vertex.
Does
that help?
Yeah.
We're looking for the vertex of this equation. So this equation is the most important. X is the side. If I was to find the vertex, I know it's 125.
Plug back.
Plug it back in.
How'd you get one negative one to A?
Equation.
This is the like in the right order so that you can see -1 is your X.
There's just no C.
No. It's going to be a really big Y value. So plug 125 back into our equation and see what we get. If you don't have your calculator, go ahead and get it or get out Desmos because we're going to be graphing in Desmos as well.
Man, screw
So I guess that's where we really should start.
Have you ever experienced? No.
The one I boxed it, the area
What is
equation.
your current situation?
I'll go back.
Plus 250x?
Y equals -x squared plus 250.
Obviously, that was all your.
Yes. Zooming out. There's my maximum. I'm gonna do like, I shouldn't have zoomed up. 300? 0 to 300?
It's like 40,000.
Yeah.
Always.
It's
not 40,000.
That was
I think.
I think I did it wrong.
That sounds right.
I did that on one night.
Yeah. So there's our quadratic. My maximum is 125, 15,625. 15,625.
I don't know, man. But it was for that. You should always be this.
No, it was Abigail.
Abracadabra.
Okay, so we already have our answer. That's it. That's how you work the question. Now let's see what that answer means and what it is.
I know it's sad. It wouldn't Abigail.
All right, what is the dimension of the largest such yard? Well, we know X is 125, so that means this has to be 125. And obviously, if it's 125 there, it's 125 here because it's a square,
Oh, it's a square.
a rectangle. Sorry. And we have to solve for Y.
Or Y back in Y.
No.
Y,
Could you just plug in X for X and then solve?
do we put 15?
125, 250 minus.
Y equals 250 minus X. Y equals 250 minus X. Well, we know X is 125. So Y equals 250 minus 125. So Y is
125.
125. So what do we do with that? So it's a square.
So why did we get 1,500? I mean 15,000.
15,625
Is the area?
is the area.
Good job.
Thank you. I just had to reach out.
Bro.
Wait, pause.
Pause.
All right, let's do it again. So I'm trying to maximize my area. To maximize that area, I need a quadratic area equation. So So that was why I did all of this work to find a quadratic area equation that I could maximize. X is the dimension. Y is my area. So this is the maximum area, this length of my field, playground, the playground this time. So what are the dimensions of the largest yard? Well, if it's a regular yard, the way to optimize it is a square. You learn that in geometry. The biggest amount of area you can fence in, like the easiest with the least amount of fencing, is always a square. It's always going to be a square.
Even a circle?
That doesn't make any sense. It's always going to be a square.
Why is the area the Y?
Because it's an area equation. So this is my area equation. So if you look up here, this is all 500 feet as well. All of this is 500 feet. So 50 by 200 only gave me 10,000 square feet of play. But 100 by 150 gave me 15,000. And then 75 by 175, 13,000. So what was it to optimize it? Well, it had to be a square.
Wait, so is that a square or rectangle?
Well, I drew a rectangle, but it has to be a
It's
square.
a square now, right?
It's a square.
Okay.
So my answer is, what are the dimensions? I'll say this A. My dimension is 125 feet by 125. And what is the largest area? 15,625 feet squared.
Wait,
What? 125.
so the first one is your dimension.
Yes, he was.
So now the owner is making a rectangle region out of 140 feet of fencing. He wants to cover the most land, so he's going to use the barn so that he doesn't have to fence in the whole sides. So here is my lovely barn.
Yeah, I never got to all that.
A barn.
What? A barn?
He's putting it next to a barn. You're not reading the questions.
This is like in geometry when you had to draw the thing.
I never said geometry.
For
What do you mean you never took geometry?
this road. We had to draw the thing. We had to find like the angle of the.
There's a lot. Look at that. There's a lot of shit to cut that.
It's a hard topic.
Okay, so now my perimeter equation changes.
What is this?
How do you draw a barn?
Is that supposed to be a rectangle?
That's
not
not a barn.
What is it? A barn.
That is
My
not
barn.
a barn.
So this is my barn, and the blue is my fencing. So I'm gonna label my sides X and this one Y. I don't need a Y over here because it's backed up to a barn, and I don't need fencing there. The cows are not magically gonna get through the barn.
I thought it was a pool.
So my perimeter equation is gonna change. So now it's not gonna be a square because I'm messing with the shape I'm drawing. I'm trying to maximize. So now my perimeter has 2 X's and only 1 Y. And the amount of fencing is always my perimeter. And we're solving for Y. Because we're solving for Y, that's why I let my sides both be X's. I could have, this is me, I decided to draw this way. I could have said 2 Y's, a Y here, and 1 X. But then solving for Y is going to be harder. Not much harder, but it would be a little harder. So if I only have 1 Y, that's the easiest way to write my equation. Because I have to solve for Y now. So solving for Y is minus over my 2X. Our goal is to get an area equation that is a quadratic.
You just plug that in Y.
Yes. So your area is X times Y still.
I hope you do that. Sorry.
No, it's already been said.
But we need to get it down to 1 variable, bless you. So I need to use negative 2X
For what?
plus 140. Hey, this time I put negative 2X first. I don't know why. Am I going too fast?
Don't ever call me that again.
So, someone says I'm reading that.
Mm-hmm.
If it says that there's something like enclosed with how many feet, just put it into that.
Your perimeter equation. You say your perimeter equation equal to your amount of fence.
Yep, I'm gonna be lost on that. I'm gonna look at that number in the equation, and I'm gonna not know what it is.
So just to simplify it, negative 2x squared plus 148.
We'll do it. I just wanna see-
Find the vertex.
Ooh, what the heck? I turned away from Ooh.
So that is the area I need to maximize. So we're gonna find the vertex of it. You can do it by hand, or you can just graph it and find the vertex.
Exactly. It's free game.
That's all you said.
You won't believe that. I've never said anything of such manner. Oh, you got that proper vocabulary. I've never said anything of such a manner. What did I learn?
That's your dad.
Must be a private. This month is-
I think it's a decimal.
Is it this one?
It's not?
35.
Is this 35?
That's what I got.
What?
Yes,
Oh, wait.
35.
I'm sorry, and I got.
So it's 35.
Sorry, I multiplied.
Technically, that's my axis of symmetry.
Why did I get this?
Hey,
Dude, that was included.
That's what.
So wait, so now do you plug 35 into the area equation or the
Yes.
perimeter?
Area equation.
What if we're looking for perimeter? Plug it in.
honestly,
I mean, you could.
so what?
I hate Subway.
So X is a length of my rectangle, and Y is the maximum area. 35 into my area equation. Or I graph it and just look at the vertex. But negative 2 times 35 squared plus 140 times 35. So negative 2 times 35 squared plus 140 times 35.
You already got me that.
But he got himself to real.
2,450.
And you can already put that into the box, right? Because that's your area. That's your area.
That's your maximum area you can find with 140 feet of fence. All right. Why not? What equation do you plug it into?
140 minus 2 times 35.
I could have charged you with the murder.
You're plugging into this equation.
Oh.
140 times 35 minus 2 times 35 squared.
Bro, that car had.
You didn't plug 35 in that.
Where did you get
Keep asking.
If they went straight, we would have done. We got lucky they turned right. Is
I
that
didn't
about
know anything right now.
Negative 2x squared plus 140.
Good enough, I don't want him sliding. Are you serious right now? It wouldn't even take special. Are you serious?
How to get the bigger number? 2,450.
Oh, if you just put it on your thumb.
You can plug it in or plug in 35 to your original equation.
Oh,
Give a big band-aid.
Wait a second. Hold on.
Once you get there, how do you find the dimensions?
Okay, so
That's the grammar.
just to see, you could use different X's and then you'll get different areas. We're using the vertex because that gives me the maximum amount of area. But if you used a different X, you would just get different areas.
Wait. But why is the vertex the area this time?
The vertex is the area. It is our maximum area we can find with 140 feet of fencing. You plug it into the equation.
No, that one.
Oh, that what? The Y here? You plug it into this equation.
Oh, you plugging 35 in that one?
Wait,
Yeah.
you plug 35 in that or you plug
Yes. Yes. Or if you know this is 35 and this is 35, what does this have to be to add up to 140? That's basically what that equation's doing.
Is it 35 squared?
So the X in this vertex, this is my 35. This is my 35. And the Y is area. What's this Y?
You just add them together. Yeah, you just add them together.
Add what together?
25.
So you can just add them together? What? I mean, that would eat some, right? Hey, chill.
What's the lie?
What is it, 70?
That's all I got.
You just always add what?
If you add them together, you get 70. And then subtract it from how much fencing you have.
I think that's.
It's 70. Just adding them together again, that's not true. Pause for 50 degrees.
And then, hold on.
No.
So, how we get 70? Oh, yeah, I see it.
So the maximum area,
I'm gonna forget this.
2,450 feet squared. The dimensions, which I didn't even ask for this time, is 35 by 70.
So once you get
This is based on
what you did.
So we wouldn't even have to find the Y.
Not this question. But most of the time I'll ask for it, so it's not bad to practice.
If we don't put feet squared, we get 1 second.
Yes, you will.
Wow.
I don't think Hey, honors ain't for me, bro.
Because how can I go with
Hey, honors ain't for me, I think.
1,200 feet of fencing, so that's your perimeter. You're drawing a rectangle with 2 caps.
Dude, is that what I think it is?
We need to write a perimeter equation. We need to write a perimeter equation. Three of the lengths are going to be the same size. And then I do 2 like this and this. But I've seen people break it up into 4 equal parts as well. I don't think that's any easier. I think you're just getting bigger numbers for no reason on that. Since we're solving for y, I like to have 2 y's and 3 x's, but it's up to you. Like, I want to label this y and these x's, but you could reverse that and still get the same answer. So these would be your y's.
It'd be 3x plus 2y equals, no, plus
3x plus 2y
plus 12.
equals our perimeter.
How many people?
Yeah, we could do that.
Oh, so that's our, P is not included.
Try that out.
Yeah.
So that is our perimeter equation.
That's a perimeter equation. So that's what I mean when I say draw and label. Think of your area equation. This is what we're trying to maximize. Write out your perimeter equation. Here are 3 options. So I've had people do other things. I've had people label this picture Y, 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 X, 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 X. That's fine. You'll still get the same answer. This is just more variables, and I don't want to use that many variables, to tell you the truth. And when it asks for the dimensions, it's talking about the whole thing, so I don't know why you would break up these into 2 x's. But you could if you wanted to. So these are just 3 examples of perimeter. Now we solved the perimeter equation for y.
Do you get fractions also?
Plug that into your area. Distribute your area formula, find your vertex, blah, 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 blah. Blah, 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 blah. That's all you hear, right?
That's the perimeter.
Wah, 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 wah.
The 3x plus 2y is the perimeter.
Perimeter equation. Solve for y, plug it into your area equation, simplify,
So whatever.
find your
number-
vertex.
Whatever number it gives you in the word equation is probably gonna be the answer to the perimeter equation.
It is 100% the answer to the perimeter equation. Not proud.
It's based on 2 stories.
Solve it for y.
So y equals 600 3 over 2.
I can't do it.
It shows right.
It's not 600. You divide the entire thing.
You're right. It is 600. So I have to divide everything by 2, and I only divided one thing by 2.
So like we scrolled it with you.
So we put in this one or?
Since it ends, decimal's fine. But if it was reversed, and you got like 1 point or like 0.33333, that you keep it in a fraction form. But since this simplifies, -1.5 is fine. Plugging it into my area equation to find my vertex. So area is x times y. Well, this is what y is. Plug it in. I'm in your way now? Well, that's because I'm always in Stephanie's way, so I thought I'd switch it up a little bit. Distribute my x, find your vertex.
Well, he liked everything.
That's what I'm trying to maximize. Any point on that graph will give me the x of n enclosure, but we want the maximum amount of area. So that's why we use the vertex.
What is that?
This does not seem like fun to do by hand.
What is it? See? Yeah.
Oh, not that bad. 2's cancel out, and then 6 negatives cancel out. 200?
Oh my god.
Yeah. 2's cancel out.
Wrong.
You like,
Dang, how do you? Wait, so whenever you try to find the max area, you plug it back in.
boom,
Yes.
boom, boom.
When you're trying to find the maximum
Oh,
area,
stop
you
it.
plug it into your area equation.
Boom, 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 boom.
Bro, stop!
AOS, is
Stop!
axis of symmetry, I think.
Mm-hmm.
Don't ever make it.
60.
Wait, which
Oh
one
my
did we use
God.
to find the second?
200.
The second y?
And then 200.
This one.
Done.
I meant the vertex one.
This one. Because you can't. Vertex is a quadratic equation.
We tried to
Maximum, whatever it's called. The y in the vertex.
Yes.
I got 60,000.
60,000?
Yeah, I got 60.
How did you know it's 200?
Oh, that's what you used to calculate
Yeah,
it.
and then there's 0.
Alright, kid.
What?
So once I get 200, I plug it into my area equation, and I get 60,000.
Can you just break that in half?
Yes, you would. It would be 2 squares.
That's what I was surprised.
Oh.
No, that was like a coach crystal. Carlos, get it off of your phone.
Wait, listen.
So this is 200, this is 200, this is 200, because that's my x. So I'm at 2, 4, 600. And then I have to break 600 from 12. I have 600 left. So that means y has to be 300 and y has to be 300.
Negative.
Alright, so I got one.
Can you
Or use your equation and plug it in.
plug in the equations? Because I got
To get y?
Yeah.
So now I know that x is
Plus bx plus
200.
200.
X is 200.
Oh yeah.
So this and that make it 100. So that's negative 300 plus 600. So 300.
Nothing like that.
Wait, why is it just 600 and not
I
600?
didn't
This
do
does no
that.
Friday. Thursday
How
night.
about not at all?
Thursday night. Friday morning.
But would it not be y equals
Yeah.
ax squared plus b?
And Thursday night. And if I need to.
No, that's quadratic. This is just one.
That's funny.
So it's just y
This is
No,
equals
actually-
plug in the.
Oh wait. Hold on, no.
So it's just y equals ax plus b?
MX plus
Every
B.
single night this week?
Yeah, they're sitting.
Okay, okay. Alright.
The slope.
How you know the slope?
This is a linear equation. But I don't know why you're asking any of that. It's just plug it in to solve for y. Thank you. So my dimensions is 200 feet by 300 feet. All right, I remember for feet. And then the largest area is 60,000 feet square.
The dimensions
Oh my god.
is
Literally 30 seconds later.
100 feet. 200 by 300. And make sure your fencing adds up. 300 and 300 is 600. 200, 200, 200 is another 600. When I add it all together, that does give me 12,000.
That's how I'm getting good grades.
Dimensions. All right, I didn't have much room.